I have a problem. Whenever I sit down to eat, I can't resist to consume some short-form videos, be it Reels or YouTube Shorts. But as soon as I do so, my lazy ass does not want to lift a finger to scroll to the next video. It really is a fight between my wanting and my laziness. So we gotta do something about it, because that's what a programmer is supposed to do. Problem solving, right? Which is why today we are going to create a script which will double our laziness, lets us enjoy our food, and keeps us hooked. Here's the plan. Since I'm on my PC, scrolling is similar to hitting the down arrow. So the idea is pretty straightforward. We have to hit the down arrow without actually hitting the down arrow. That's it. That's everything we need to do. This can be achieved by a few lines of code, but this isn't what we are looking for. We need the down arrow to be pressed on a specific time, whenever we want, for which we need a stimulus. A stimulus is something that causes a change or activity. In computers, a stimulus can be of many types. It can be in the form of a mouse click, a key press, or something within the software. In our case, we need something engaging, something which connects to us directly, and by direct contact, I knew right away what I was going to use. The most unused piece of hardware in a PC, the camera. The camera can be pretty useful in situations like this where we need to perform a stimuli. Now we have the stimuli, but we need a way to somehow play around with it. And thanks to the Google developers, we have on-device machine learning models for video. On-device machine learning refers to the running of machine learning models directly on your own machine, instead of relying on a remote server or an internet connection. A library called MediaPipe, developed by Google, can be used for building machine learning pipelines for processing data, like video. Basically, these guys compiled and fed hundreds and thousands of images and videos to the model. These were subsequently processed through specific technology, so whenever you try to utilize the model is smart enough to understand what's going on. In our context, whenever you feed the library with some input video or image, say of your hand, it has already been through thousands of hands and understood what a hand means, so it can easily recognize it and perform specific tasks accordingly. Now, for the task, we can do a whole lot of things. You see, this model has something called landmarks, which it uses to recognize a hand. These landmarks are basically different points on your hand, which are used for the recognition. With a few lines of code and another library called OpenCV, which is commonly used for video capture and processing, we had the model running and recognizing our hand. In return, the model returns some data, like the coordinates of each landmark when their position changes, and we can do a whole lot of things with this data, like feeding stimulus to the computer. Using basic maths, I did some simple calculations. Basically, I targeted a single landmark on my finger and created a line from the top of the screen to this particular landmark. Whenever there is a movement in my hand, the code calculates the change between the initial and the final point. If the change is more than a specific limit, I fake a swipe. For the limit of the change, I played around with it and chose what fits my need. The code is in the description. Feel free to check and try it out for yourself. Now, everything was in the right place, but using my hand didn't seem to be optimal, as this required some considerable amount of activity. So thank you to Google again. The MediaPipe library supports face recognition also, so I went ahead and used my head to fake the swipe instead. I copied over the same logic for the face script, but this time I targeted the landmark on my chin for a near accurate calculation. This converted the fake swipe into a simple nod of my head. In a nod, when the head falls and rises, I calculate the change between the two movements. If the change is reasonable and large, I hit the down arrow. To press the down arrow, I used another library called PyAutoGUI, which is widely used for mouse and keyboard interactions like clicking and pressing buttons. With this addition, the script was ready. All we had to do now was to get started. Now, to even intensify my laziness, I got the web browser library so that I don't have to manually open the Shorts page. This library helps to do browser-related stuff like opening links, handling browser events, and many more. Finally, I put it all together and we have a working script. I created a shortcut of this script on the desktop for easy access, and we are all set. Here is a full functioning demo of the script. Enjoy and keep scrolling. If you think I missed something, feel free to contribute to the project. The link to the project is in the description. Thank you for watching.